Yeah.
Hello, everyone. I'm happy to be back with another young Indian. Right now, we have with us Akshay Pachore. Let's listen to him. Over to you, Akshay.
Thank you, Dr. Mathur, for this opportunity to speak about myself and more than that, about my work, which I am doing at IIT Kharagpur right now. So I'm a research scholar here. I'm a fourth year Ph.D. student. I'm enrolled in a school of water resources, and my particular focused area of research is flash drought modeling for India. So I have a short presentation based on my work. So I can speak based on that, the particulars of the work I'm doing right now.
I'm going to put you on pause, and then once you are ready, we will come out of the pause. Okay. We are out of the pause. Akshay is ready. Please go ahead.
Yeah. So broadly, we are working on the flash droughts, and we are all known to the seasonal droughts, the long-term droughts. So we are particularly here working on the flash droughts, which is an emerging phenomena right now. Scientists have identified since 2012. So because there was a vast devastating droughts in US. After that, people started working on the flash droughts. So here I am particularly working on the drivers, characterization, and impacts of the flash droughts. So for the sake of knowing what is flash drought is, it is the agricultural drought. It is based on the soil moisture, and it's based on the soil moisture depletion, and that depletion is the quick. So there is a rapid decline in the soil moisture, and also there is a minimum duration criteria for the event. So all this is the land-based phenomena as it is an agricultural drought, but it is triggered by the atmosphere, right? So it is triggered by the precipitation, temperature, and evapotranspiration. As there will be the precipitation deficit, and at the same time there will be the high temperature and high evapotranspiration phenomena that that combination will trigger the flash droughts. And these atmospheric variables are again largely triggered by the ocean phenomena happening in the Pacific Ocean and in the Indian Ocean as well. So in Pacific Ocean, it's happening, ENSO is happening. In Indian Ocean, IOD is happening. So this is what broadly we are looking into. So giving the brief background of the droughts. So drought is the normal recurrent feature of the climate, and it is varies in terms of its spatial extent, its intensity and duration. So these are some newspaper headlines about the droughts happening in the India. So how India is losing its farmland and its yield because of this drought situation. So taking you to the properties of a drought. So like floods and other extreme events, droughts don't have a universal definition because it is varying from one region to other region. So droughts in Rajasthan are quite different from droughts in West Bengal or droughts in Kerala. So these are all climatically different regions. Also, it varies from one season to other season because we have every season has a different kind of a water availability characteristic. Drought are mostly classified into four types broadly: meteorological based on rainfall, hydrological based on stream flow and groundwater, agricultural based on soil moisture and crop yield, and the last one is the cascading, the final impact on the socio-economic conditions. So that is the socio-economic drought. The impacts are agricultural distress, migration, and ecosystem degradation. So while talking about the flash droughts, we can see these newspaper headlines about the flash droughts worldwide because of the warming climate. Flash droughts are intensifying. Also in India, people are working on the flash droughts and they are marketing the areas, the hotspot for the flash droughts. So the next is the drought propagation. So we know it's not like the standalone phenomena. It's starting from the rainfall deficit or maybe from the oceanic and atmospheric anomalies. Then it is coming to the rainfall deficit. Then it is affecting the soil moisture and your overall surface water balance. So that's how it is propagating through the overall system, hydrological system. So here I have shown you these This is the propagation mechanism of the droughts. So it starts with the precipitation stress signal. Then there is a reduction in the surface water and groundwater. Then there is a reduction in the soil water in crop root zone depth. So this is how the phenomenon is propagating.
Okay.
So here I am showing one science paper published in 2023. So it is based on the global transition to flash droughts under climate change.
Yeah.
So if you see here, it's a figure A. If you see, it's a ratio of flash droughts to subseasonal droughts. Now, subseasonal droughts are occurring within one season, but these are not flash droughts. These are the total droughts, like total like combined flash droughts and slow evolving droughts combined, total number. So if you have 100 subseasonal droughts, out of which how many are the flash droughts? So here we can see India. If you see the this red part, it's like almost 70 to 80%. That proportion is flash drought. So that is kind of a hotspot they have identified for the India. So this is what this science paper says, and it's showing this there will be a shift from slow evolving drought to the flash droughts in the warming climate. So that's we are going to face now. So these are some results based on our work we are doing here right now. So so this is what the spatial pattern we have identified so far for the different seasons. So we have identified the droughts for all India. These are the flash drought spatial pattern. So this is the frequency of flash droughts, and if you see the Indo-Gangetic plain and the west central part. So these are the all homogeneous rainfall regions of India. 6 regions are there. So based on rainfall homogeneity. So based on rainfall homogeneity, the IMD has demarcated the 6 rainfall regions for India. So here we have identified like central northeast and west central. That part is kind of giving high flash drought frequency for the monsoon season. So I know there will be like lots of question based on this, like because it's like the flash drought itself or any drought for itself. It's a seasonally having different thresholds. So it's a seasonal characteristics, and each season having a different water balance. So based on that threshold we define, and based on that that drought is particular to that particular season. So it's not like people will ask like why you are getting more number in the monsoon when we are expecting the higher rainfall in the monsoon season. Still the droughts are there. So the simple, like I have answered this question for like so many times now. So, but the simple answer is if I'm used to a glass of water in a monsoon season, right, and I'm not getting it for particular year of particular monsoon, right, then I can say there is a scarcity, right? If I'm used to something and I'm not getting in, then then only I will define the scarcity. But if I go to the pre-monsoon season, that is a summer season in India, I'm not used to get a water. So if I'm not used to get a water, and if there is no water, then how I will define there is a scarcity, right? There is no scarcity in that particular season. Okay. So India is used to droughts in a monsoon and post-monsoon season only, effect of which is on the overall water balance, which is getting cascaded to the other seasons. So it is as simple as.
Yeah, okay. So can I sort of come in here, Akshay? It's an important point. I want to put it in another language and see if it's correct. You are defining this drought as compared to the norm for the season for the place. If you are below the norm, it doesn't matter how much absolute value is. If you are below the norm, that's a drought because that's going to affect your entire cycle. Is that exactly right? So if the norm is very little rain and you get a lot of rain, then you have a problem. And if the norm is a lot of rain, but you get only 70% of that, then you have a scarcity.
Yeah.
Okay, fine. This is the first time I'm hearing these things, so I just want to know that I understand it. Okay.
Yeah, it's fine. Like even people working in the field have same question, so I don't mind.
Okay, let's go.
Yeah. So it's like just to put it like it's it should be like people generally take the 50% anomaly. So if it's the value goes below the mean, then it's a drought. But in flash droughts, it's quite different. It's like depending on the onset rate, and it's like different technical aspects. The framework I don't want to discuss, but it's basically the baseline is like this. If it goes below the season specific threshold, then it's a drought. Yeah.
Okay.
So these, yeah. So this is like large scale drivers of flash droughts we have identified. So if you see, and so this is the El Nino Southern Oscillation has three phases, kind of two phases, El Nino and La Nina, and one is the neutral phase.
Mm.
So for India, if it's El Nino, it's a drought condition. It's a scarcity because the monsoon winds will deviate towards the north and
Yeah.
South America, right?
Yeah.
And if it's a La Nina, it's a flood condition in India.
Yeah.
So it's a wet condition. Wet condition will get intensified. And if it's a neutral phase, it's a neutral. The effect is neutral. Similarly, it's a positive and negative IOD phenomena is there. If it's a positive IOD, monsoon gets intensifies, and if it's a negative IOD, monsoon weakens. So if you see overall dynamics of these drivers, you see it follows the physics. La Nina is having the smallest proportion of flash droughts because it's a flood situation, wet situation in India. Neutral follows the next highest, and El Nino follows the highest one because it is intensifying the dry conditions. So the same thing we have found the all six regions are following the same pattern. So next is this is the list of La Nina, neutral, El Nino, PIOD and NIOD years. So the next is the co-occurrence years of different ENSO and IOD phases. And this is the co-occurrence frequency, like the some particular El Nino and PIOD is occurring at the same time. It's the dry condition from the Pacific and the positive IOD, which will actually nullify the El Nino effect. So how the flash drought frequency will vary in that case from one season to other. And the other one is the El Nino and negative IOD, which is the more severe combination. So if that happens, like what will be the situation? So we have checked for El Nino and positive negative IOD combinations. We have also checked for neutral and positive negative IOD combinations. So we have observed like the monsoon season will have the higher frequency for El Nino and positive IOD, but it will go down till the post-monsoon because positive IOD will intensify in the post-monsoon season, which will cause the reduction in the El Nino effect. So positive IOD, which is strengthening the monsoon and nullifying the El Nino effect, is having the peak stage in the post-monsoon season. So that's the reason this dynamics is reducing from monsoon to post-monsoon like that.
Yeah.
So next we have performed the causal analysis. So causality, we have checked between the flash droughts frequency and the large scale drivers. So here I have just depicted the how the causality works. So it's different from the normal correlation, just like simple correlation. So there will be the causal links. So arrow will direct. So arrow will show you the cause effect relation. So X, if you see here, X1 is the arrow towards the Y.
Yes.
So straight link will show you the X1 is causing Y. It's driving Y.
Yeah.
Right? The lagged causal link, the curved link will show you X1 is causing Y, but in the lag time state.
Yeah.
And if it's a straight link, it is driving Y in a real time.
Okay.
So it's real time causation and lag time causation we have checked here.
Yeah.
So this is the overall. We have found our results are like this, that flash drought frequency is like mostly getting affected in the southern peninsular and west central region because of the DMI. DMI is the proxy for the IOD, Indian Ocean Dipole. And again, the Indian Ocean Dipole and the Nino 3.4, which is the proxy for the ENSO, El Nino Southern Oscillation, having the real time as well as lagged causal connection. So this is the impact thing we have checked. So this is like very recent result we got for the GPP, which is the gross primary productivity, and soil moisture, which is the anomaly we use to define the flash droughts. how this flash droughts and GPP, the gross primary productivity, is connected. So interestingly, we can observe the positive and negative feedback mechanism, like driving as well as like the flash droughts are driving GPP in the real time as well as the lag time. But at the same time, when GPP triggers, when your gross primary productivity of the crops, it is based on the photosynthesis rate. So when there is a greening of a vegetation, when there is a higher greening of a vegetation, that higher greening will cause a higher need of soil moisture, which will cause the quick depletion in the soil moisture and the coming flash drought phenomena. So that way, this is how the entire dynamics is working. So this is the entire thing I have. So these are few publications we have done so far based on our work on droughts. So published in scientific.
Okay, let's get out of this.
Yeah.
Screen share.
Yeah, sure.
And tell us how you got here.
Yeah, so I am a civil engineer. In my bachelor's, I did a civil engineering from Pune University. So after that, I was quite interested in research. So I pursued my master's from Aurangabad in Maharashtra. It's a government engineering college there. So I did the same topic, droughts, but based on the Marathwada region of Maharashtra. So after that, I like for 1.5 years, I was working in a Central Water and Power Research Station. It's a CWPRS, Central Government R&D in Pune. I was working on this World Bank funded project on under National Hydrology Project. It was a National Hydrology Project funded by World Bank, and I was working on the river rejuvenation project there for 1.5 years. So after working there, it was very clear like I want to pursue my further research and I want to do PhD. So I applied to IIT Kharagpur and I started my PhD in 2020. So it's like almost more than 3.5 years here. This is how the journey is.
Okay. And some highlights of your journey that you can share with us.
Highlights so far, it's like a very I was very uh, I started doing research because of my passion towards it. But I never thought like coming from a small village in Maharashtra, I will come to IIT Kharagpur one day. And like kind of I have seen the entire ecosystem of Indian education now. So I was in a government school, I was in a private college, I was in a government college, I was in a central R&D. Now I am in IIT. So I know the.
Congratulations. That's a very impressive journey. It took you several steps because of where you started, but you have taken giant steps and ultimately reached the top. That is PhD from IIT Kharagpur. It has a lot of meaning, and congratulations on it. It's very impressive. I mean, in a way, as I say to people, that, I started this channel for young people because I know how good they are. And society is still thinking, oh, these juniors, they don't know anything. We are the seniors, we know everything. And I was fed up of it. I said, guys, you don't know how good these people are, and you don't know where they've come from and how they have climbed and made it. So you have just validated my concept of this model, which was based on just two hunches. One, young people are very good because they absorb a lot of information from various sources, which was not possible in our time. So we are stuck with that old mentality. What do the young people know? And number two, that the old society is stuck there. So somebody needs to break that barrier. And why is somebody? Me, I'm here. So here we have a proof that people are making their way forward. And it's a path that will help other people in your village, other people in the small towns, that yes, I too can do it. And that's what we need. As an economist, I talk about equality of opportunity, right? And that we don't have. But still, some people make it, right? Because once you're in a village, what is the opportunity? There is no opportunity, but some people make it. So what I'm saying is that you've shown us a way forward, and that's very good. Okay, and let's what my response is, and of course, I had never heard of the term flash drought. So I'm learning also a little bit here that look, in the old days, we used to only talk drought lasting 1 year, 2 years, 3 years, right? That's long-term drought, okay? It has not rained properly for 3 years, there's a drought and cattle are dying and this and that. What you're telling us is that that's one thing, but there's also a flash drought, which can actually, today we are not so food insecure in the country, but we are still income insecure. The income of the farmer still depends upon the output. Right? And if the farmer's output in a region is affected by a flash drought, then we'll have to take care of it in some way. Now, right now, I don't know whether there's any understanding of this at all in the government circles and all, because still very fresh research work. So I'm glad you are doing it. It's wonderful to hear it.
Yeah, thank you. And I would like to know, I have a question for you.
Okay,
you
please
allow me
ask.
to. Yeah. So, from an economist point of view, we are working in the hydrology domain, so we see things we don't see the socio-economic impact of those aspects. But what is your insight, how this water stress conditions can actually cause the larger scale impacts on the society, especially in the lens of this climate change phenomena, I'm not talking about the climate change also, even in the normal conditions, farmers are not aware of the proper forecasts.
So
That
okay,
is
let me answer your question. There is a growing field called ag tech. Okay. And ag tech basically means that these guys are putting sensors on the farm, or they are just taking sensing data from satellite or from drones, right? There are three ways: satellite, drone, and sensors on the ground, right? And they are actually calculating risk. Okay, so one is to calculate the risk so that they can inform, actually the farmers have taken loans or whatever, and they are talking to the lenders that this is the risk situation. And to the farmers also, they can deliver information that, look, this part of your field is dry. Either my sensors tell me, or my drone tells me, or my satellite tells me that this part, especially if you have large, it's not very small, very, in India, a lot of the farms are very small. So they can actually observe it themselves. When the farm is large, then you cannot observe it all the time. But whatever, they can still give you, and they can take the most recent forecast of weather, short term, and tailor it to your needs. So, but that's a very specific tool or information per farm, per farmer. What is missing there is what you have just said. That, look, I can go for the region. Right? I'm not going to say this farm. Okay, I'm going to say, look, this region this year, there's a high probability of a flash drought. Then how do we prepare for it? We don't know yet. I don't know it. I haven't thought about it. Nobody's thought about it. But we need to think about it. And broadly speaking, if we classify this as not just a problem by itself, but as a problem of adaptation, and we can put it under the rubric of climate change, because climate change is going to make it worse. Right? So it's adaptation to the climate and to the climate change. And why? Because the change is coming not just from greenhouse gas, but who knows why this has emerged since 2012. I don't know. You may know, but you don't know the causal factors, because you are just saying these are the drivers. This is the things in the ocean, and this is. But why is it happening in the ocean? That you say no. This is not my concern. I know it's happening, but so we can just put it as a adaptation of Indian agriculture. I'm very interested in that. As an economist, I would say let's call this as a tool for Indian agriculture and policymakers to have an adaptation strategy. That if it's in the West Central, we are going to have this issue, then we can't wait to have this issue and then prepare a plan. Let's think about it now. What can we do? What can be the, and I don't know whether anything can be done because it is a thing which I have no knowledge about. I'm just hearing it for the first time, but that's where I would look at it, to put it in the broader context of modernizing and updating Indian agriculture.
Yeah.
And one issue will be actually the variability in the availability of water.
Yeah.
So what crops do we grow that are less vulnerable to water availability?
Right.
Already there is some movement, grow ragi, grow this, grow that, but that may be more focused on shortage of water. But what you are saying is even in a non-shortage water, there may be variations that can make a difference. Anyway, that's just my understanding, and we can talk about it at, once this. I want to talk to you a little bit about it offline, but
Sure.
anything else you want to tell us?
Yeah. So like it was a really wise point about the adaptation, about the climate adaptation. I believe in a climate adaptation of agriculture as well as the urban society, not only agriculture. We need a broader adaptation as a society, as a policy as well. But what I see lacking is like, I'm not criticizing the policy, but the implementation is lacking. Farmers are not aware of the situation, how it is warming and how it is affecting them. They are suffering from it, but they are not aware of it. Same to the urban population. People are dying because of heat strokes.
Right.
They don't know it is happening because of the warming and urban heat island effects and heat waves. That's what I feel like the implementation needs to be focused.
Okay. All right. Anything else you want to add here?
I don't have any specific right now, but like I think like there should be more efforts as a society towards the environmental studies. So we should not think like what is this is just this is the normal environment. It's there since so much time. So it's not like that. The situation is really changing, and I am really scared about the future. So this changing climate and overall scenario. So I want everyone to be aware of it, everyone to be just take care of their own environment at least.
Okay, all right. Thank you, Akshay. It was a great learning thing for me to listen to you. I'll be back with another young person or an expert soon. Till then, bye everybody.